Hey, Gary and Mark, welcome to the show.
Hey,
Thanks,
Steve. How you
Steve. Thanks for having us.
Yeah, it's good to have you on. I'm real excited about this conversation. I know we were talking a little bit at MPP East about a month ago and saying how cool it was to see kind of a startup in MedTech, especially in the micro molding space and in New England, right?
Yeah.
We're all, I was born and raised in Connecticut, so we're all New Englanders. And even though I've been down south here for over 20 years, it's good to see a startup here there in New England. So I'm real excited about this conversation. Talk about some of the gaps that you're filling and the tech platform that you offer, the 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 investment that you've taken in the facility, the equipment, the molding machines, and obviously some great talent as well. And so we'll get into that. But before we do that, Gary, if you can kind of just tell us a little bit about your journey in micro molding and your launching RPM.
Yeah. So it kind of all started back when I was probably 15 years old. I worked for a one-man tool making shop here in Leominster. So he was a guy who kind of taught me, everything he knew about the business, which one of the things he was so adamant about, which at the time I didn't understand, it was cash flow. He made me deliver the mold and wait for the check. So sometimes I was helping him load them, helping the company, the plastic company we were delivering the mold to, helping them load it into the press. And because the guy's like, I ain't paying you because I didn't shoot it yet. I'm like, well, that's why I'm here to help you. And he's like, don't come back without a check. so so
Cash is king, as they say, right?
business at a very early age, not just tool making. Being a one man show, you have to do everything from design the tool to order the stuff to machining and delivering and all that. I worked with him until he finally called it quits, and like him, he moved, like most people, he moved to Florida to kind of enjoy some retirement and some nice weather. So I worked at various other places, Nitro, Milling the Mold, all those places. I always kind of worked as either a department lead or department head for the tool making because I was literally one of the only people that had like even a little bit of plastics background, in tool making to be able to, kind of help other people with, phenomenons that are happening with plastic parts. And, you send it out for repair and people don't understand, a lot of tool makers never even put a mold in a molding press before. So I had that experience. So I was always willing to help people out. And I really, really enjoyed that more than mold making itself. So, fast forward, I spent the last 24 years at a micro molding company to really focus on, the micro aspect of it. And, I kind of left there, back in November, kind of, not knowing what I was going to do. Am I just going to retire? But I felt as though I had more to offer the industry, and I wasn't really ready to retire. After sitting home for a couple months, it was like, what do I do now? So got together with my son and some other team members, and Mark, was great. And it's like, hey, we have some, ideas, and we also have some money. So why don't we, you know, build our own company? And I was like, you know what, this sounds great. It's, something I can do with my son. My daughter also works here. She's a metrologist too. So, very smart and, very good with computers and measurement systems, and blueprint reading kind of came natural to her. So it's like, hey, what more to, say to have kind of you're working with your son and your daughter and also Mark. We've been friends for
Yeah,
20 plus years anyway. So we kind of know each other and kind of built a relationship between us. So that's kind of, again, my background and kind of how or why we started RPM.
that's excellent. Thanks for that, Mark. You want to chime in? I know you've seen these. I know you've known these guys for a long time.
Yeah. It's pretty much what Gary said when he, approached me with the idea. I felt that there was some space in the marketplace, and he was able to articulate a business vision and a business plan. And then, we got a group of guys together and kind of formalized it. And as Gary mentioned, I think it's important to be well capitalized when you're starting something like this. It's very capital intensive business. You have to bring in elite talent, and these things cost money. So when we kind of went through it and we had a business plan and we had the capital to execute it, the rest just kind of fell into a place. Gary was able to secure a location in Leominster, which is near a lot of our team members. It already had a clean room, kind of gave us a little bit of a start to get going a little bit quickly. And a matter of fact, I think we're going to be thinking about the official grand opening sometime in September. Even so, we're already up and the dual room is just about functioning. We got a few machines being qualified. But, you know, when we invite folks like you and the press and customers and whatnot, it'll be probably couple of months from now, in the early fall. So, yeah, I think it was really the team. You know, one thing I always like to bring up is we talk about the tech, and we're going to talk about the tech because it's important. But, you know, these businesses are run by people and cultures. And I think we have that in what it takes. And that's what really got me excited.
Yeah, no doubt. Look, even extrusion, molding, whatever the polymer processing, and in particular MedTech, one of the biggest challenges anybody faces is talent, right? And you've been able to put together a real best-in-class leadership team. I know Patrick, he's been on different MPP panels. He's just, he's always great to get on because he's so smart. And the capital is key, right? Look at the facility. I saw the LinkedIn page, 3 Sodic machines. This all comes at a huge cost, right?
Right.
Yeah, because you're not just talking about the machines. You know, you buy a $150,000 machine, and you need a $50,000 robot. You need a $15,000 dryer. You need a $15,000 mold heater. You know, that cooling water. You know, so it's a significant investment.
Yeah. When you're talking about micro, a lot of times you're talking work cells, right? You're talking cameras, automation, all sorts of things to handle the parts downstream, you know, and that's what we're going to be specializing in. And, you know, as Gary said, it's a system, right?
Yeah. Like Gary mentioned, even before we went on the podcast, he's talking about his daughter and how she has this unique skill of metrology and measuring these and doing fixtures for measuring these micro parts. And he said if she saw like a macro part in her hand, she wouldn't know what to do with it.
And it takes a lot of special expertise, as you mentioned, just to deal with these kind of things that, you know, you certainly can't see with the naked eye. And you still have to deal with them and handle them and get some data from them.
Yeah. You know, one thing I like to ask when I'm doing a podcast, whether it's with a founder of a new medical device company or a tech leader that has developed a new tech platform, it's always good to understand what is the unmet need or the gap in the industry, in the ecosystem right now that you're trying to fill. And then we can go into some of the tech platforms, resources, et cetera, materials, expertise, that the tech that helps you solve that gap. But Gary, I'll start with you. What is the gap in the industry, in particular for micro medical molding?
Yeah. So, you know, everything that I've learned, you know, throughout the years dealing with all the OEMs is if a device is going to fail, they want it to fail fast, you know, when they're iterating. You know, they can't wait, you know, 8 or 12 weeks for parts in hand or say, oh, this didn't work, and let's try changing this, and now you're going to turn around. So, I mean, the name of the game, where the RPM name came from, is speed to market. You know, a lot of OEMs can relate to that. You know, if you're entering into, you know, say $100 million med device market, you know, everybody knows the first one to get to that market is going to get the leading share of that. So, in a lot of times, you know, we've seen, you know, say startups and, you know, major OEM competing for the same market, and the major OEM gets there first, and the startups kind of just fold because they're not going to get the return on their investment. And they, you know, major OEM has already got that market share. So it's like, why bother? And I've seen a lot of them close up because of that, you know, years and years of developing a device and someone else beats them to the market. So I found there was a big gap in the speed, you know. So what, you know, we're trying to do is like cut that lead time, all those lead times in half. here, and we have a lot of equipment, vertically integrated tooling. We have 24/7 DFM work going on to help get the tool going. We have some creative, shifts to make sure that the machines are always running to get the tool done. And we have some optional partners too that can help with either partial tool build or complete molds in Asia. So we have, what I believe is we have more options to get you to the market faster than most micro molders in the country.
I think the ability for in-house tooling development is critical to that, right?
Yeah. And another team member too, Kyle Kolb, I've been working with him for, 35 years, and he truly is, I like to say he's one of the best mold designers out there, in the country. And I've said that to people and they saw some of his work and they're like, you know what, you're probably right. So he kind of leads all the DFM discussion, which is nice because he's like a product designer too and a mold designer. So he can help with, what the customer is trying to achieve, but also make it so that we can tool it up. And it's a robust tool situation where, a lot of times, product designers are just designing the part for function and they don't really care about the scalability of this and the maintenance that's going along with the features they're trying to create. And that's where Kyle really has a strong hold on that kind of aspect.
What kind of, you have somebody like Kyle that has 35 plus years experience and a lot of tribal knowledge. What's the balance between that experience and then using some of these tools like scientific molding tools, mold flow and things like that? Are they used in conjunction, or walk us through a little bit of that process?
Yeah. So Kyle doesn't do like DFM work without Pat Haney, So Patrick Haney is always involved with any kind of DFM for the customers, and he talks about how the materials are going to behave. With Kyle, they're running mold flows, they're changing gate locations, they're always working very closely together. Like when we do a DFM call with the customer, it's usually myself, Kyle, and Pat. 99% of the time, we're all talking to the customer about the different facets of the tool build and the project itself.
Okay. You talked a little bit about, Patrick in particular, about the materials. Can you share with us some of the materials that you work with? I know there's commodity materials and then there's some more complex advanced materials, bioresorbables. If you can go through some of those.
Yeah. So, we do a lot of, the big demand, because it's easy for the OEMs because the implantable grade peaks come with all the biostability data. So peak is always a popular option for our customers, to get speed to market because it eliminates some of the testing that they need to do to be able to sell this, in the markets that they're looking to. So peak is a huge one, and peak has come out with a lot of different fillers. There's anything from nanotubes to carbon fiber to glass filled, and they all carry that, biostability data. So it's a very popular option, but it's also the most expensive, one of the most expensive materials to process, to build the tool for, to purchase, so you really need to know what you're doing with those materials to create success, and that's where Kyle comes in with working with Pat about the heating strategy. You can't just throw electric heaters in a mold or oil line in a mold and call it good. We go to the point of, getting the thermocouples as close to the mold surface as we can. And then Pat's finding these spot heaters to be able to control the cavity, because it all comes down to your cavity control in micro stuff. You don't care what the mold base temperature is. It doesn't really reflect what's going on inside the mold cavity.
Yeah. It's interesting. You said, you kind of alluded to predicate materials because they're easier to get through regulatory, right? And I remember doing a podcast with somebody at Edwards Life Sciences, a polymer scientist, and she's like, in MedTech, we're using the same materials that we used 20 years ago, because especially for implantable, it takes you over 20 years to get regulatory approval and all that. But what the advancements in materials are kind of like you said, different additives to give different functionality. He talked about glass and some of those things. And you can just kind of share some of those value added approaches to some of the base materials like that are,
Yeah.
go ahead.
So even the bioresorbables now,
Yeah.
people, they just wanted to, originally started as staples and sutures, so they dissolve. But now we're getting into compounding drugs, for almost drug delivery devices. So as the bioabsorbable dissolves, there's pharma that gets released, so dealing with those specialty materials with, our equipment and the way we create a melt is so gentle that it doesn't destroy, the pharma or the polymers. So you always get, what the scientists believe they've formulated, you're always getting the exact result when it comes to the end product. Because as the scientists are not molding people, they rely on us. You'll be able to process
Yeah.
this material correctly to get the results they're looking for.
That's a good point. You start out with a really good base material, but it's the processing that maybe gets, for instance, peak amorphous versus crystalline, or bioreabsorbable that's heat sensitive, especially with a drug in it. You don't want to destroy the characteristics or efficacy.
Right. But yeah, then there's even, polypropylenes. There's recently a company that does an implant-grade polypropylene that had all the biostability data. So there's a lot of materials out there. Polypropylene is $1 or something a pound.
Yeah.
Once you have it for implant-grade, it's tens of thousands of dollars a pound. But it comes with all the certifications and all those specialty things that help for speed to market.
Yeah. Mark, in your experience in MedTech, pretty vast over the years, working with a wide range of molding and other applications. You see that the same thing that I alluded to in the materials. There's kind of these predicates that stick around, but
Absolutely. We have a lot of risk averseness out there too in our industry for obvious reasons. So certainly, and I think some of the development you guys already talked about with some of the additives and some of the different things. But I guess the thing that I'd like to add here too, it's the micro molding. When we all talk about it, it's a marriage. It's a really delicate balance between the tooling, the material, the machine, the metrology. When we're taking on a project, you have to address all these things up front. You can't, kind of just loosey goosey, oh, we don't need to worry about that, or have it as an afterthought. These things have to be front and center. And I think that's where the experience comes in with Gary and his team. I mean, I've already seen in a couple of early stage projects, they're asking questions that, I don't typically ask in my day. And when I was working on, say, normal molds, there's a lot more there. And then, you're educating the customers. They're going into some areas that they're not really familiar with, which is why they're reaching out to us. So, and of course, I think the flag over Gary's heads makes a statement too, because this is all made in the USA, and with, all in anything that's, say, maybe sensitive or whatnot, that's also a lot of that's going on in micro molding, right? People are doing cutting edge applications. Like Gary said, they're trying to get first to market in an implant or a specialty catheter or whatnot. And, by being local, by having a local supply chain, by having that speed, that RPM, that rapid, we can call it rapid product management, rapid production, rapid precision molding. We intentionally in the RPM gives you that, connotation of speed, of fast. So, I mean, really, I think, that's what we're trying to be. And I think we have the team to pull it off.
Excellent. We talked about the world-class team that you have, and tooling design and the collaboration, the DFM with Patrick and your tooling designer. And I want to dig a little bit more into the metrology, because measuring, whether it's a micro extrusion, a micro machined part, this is kind of where one of the real challenges, not only to produce these parts, but to accurately measure them and then get in alignment with, you mentioned Mark, they're new, get in alignment with your customer on how you're measuring these things. Can you walk us through a little bit? That's a huge challenge. And you mentioned your daughter's like really good at that. So make sure she stays with you a long time to treat her good.
No. She will be with us for a long time.
Okay.
Yeah, no, the metrology. So, as Mark said, it's a marriage. Like when we get an order for a new project, we're looking at, even when Kyle's looking at the tooling aspect of it, he's working with my daughter Gracie on how we're going to measure these parts, because a lot of these are, micron level tolerances. And as you know, you try and do a gauge R&R with something, if you're 30% of a couple microns, that fills the gauge R&R. So he works really well with Kyle in creating, fixturing, because as she said too, it's like, okay, we know the parts are pretty consistent, but how do we cut down the noise in the measurement system? Because that's pretty much what we're measuring at this point.
Yeah. Exactly.
Different way of looking at it.
Yeah.
Companies, but she has the support of, some very talented people. And even Patrick, he's not only good with materials, he's also, involved in, getting us our 1345 certification, and writing some of the procedures. And so is Gracie. So they all work together. And if you could, bottle up the passion that we have here while we're building this, people would pay a lot of money for that bottle.
Absolutely. Yeah. So that's a big challenge, just the metrology, inspection, gauge R&R, calibration, and along those same lines, there's a massive difference between kind of a macro molding operation and a micro molding operation. If you can kind of just, either one of you guys, you want to share your thoughts on that, it's a huge difference, right?
Yeah, well, Gary touched on a lot of it already. The material costs can be very expensive. So one example, I think we talked a little bit about it at MPP, Pat brought it up. Somebody might have a bag of resin that's going to last 10 years, and they'll want that. They'll want to purchase a 10-year supply so they don't have any lot to lot variation, right? That's how sensitive some of these projects are. So that's just kind of one example, but maybe Gary can share a couple other ones.
Yeah.
That's good.
When it comes to, say, scientific molding, which is kind of standard in the med device industry, so there are some significant differences in between micro and macro when it comes to that. There is some, and Patrick Haney would be the best to talk about it, but there's a few things that, that I know, like, in a macro part, you do a gate seal study, which is time and weight and all that stuff. Well, when we're dealing with parts, that are, the 8 decimal placement on the gram scale, it's you're kind of measuring the noise. So did the process make any changes there? But the biggest thing is, like, we're only interested in like the last 1% of that process, because that's what's filling the part. So a lot of people don't get that, and they don't realize that, all the things that we're doing only affects the last percent, which is when the material's the coldest, it's all the most stress, So that's kind of crazy when you think about it. When you're developing a process, realistically, the last percent or less than 1% is really the part. And, you're looking at it to, make sure that it ejects correctly and that it's, dimensionally stable and all that stuff.
Yeah, one of the things I'd like to add is we were just talking about, for example, Steve, Patrick and Gary and the team and Kyle, they've done a lot of work in the past, and we're going to continue to do more work at RPM on material characterization, which we're doing now. So this is not done in conventional molding. I've been doing that conventional molding for almost 40 years, and you don't do, but we're making our own tensile bars. We're making miniature form factors that we can characterize materials. There's a lot of different phenomena, to Gary's point, that, Patrick again brought him up. You go from Newtonian to non-Newtonian, and as you get into these micro features in the stresses that you're imparting in the shear and in the wall. So it's really the trade secrets, the tribal knowledge that you mentioned is super important. And it's important for our clients, because as Gary said, that's what allows us to fast track a project, because we'll have characterized the materials and say, listen, you can't do that with this material. We know that. We can't flow it at this length on a 3,000th wall. It's not going to work. Now, we just saved them a lot of pain, time, and money, because we've already done that homework for them, and we can show them the data. So I think these things are some of the differentials and super important for us to achieve that rapid goal that, Gary mentioned and is one of our, linchpins of our offering.
That's a great point. That's a great offering to be able to characterize those materials. And it goes back a little bit as well to what you said about when you were referring to what Patrick said about lot to lot variation, right? You can kind of make sure you don't have that variation by characterizing those even before you work with them.
Yeah. And if there's something that we don't have internally to start out, as you know, we have to be very judicious with our capital. We have outside partners that can help us with these services. Gary and his team are aware of the local guys that can give us a CT scan, or somebody that can help us with some additional testing or whatnot that we may not be able to do on day one in-house. So, that's where we're going to, we'll fill out those gaps and decide what to add in-house as we move along, see what projects are coming in the door. We're going to be working on some overmolding projects. Those are in the catheter market, maybe doing some micro catheters. We already have our first vertical machine in the clean room ready to go. We've got a couple of tools being built. So, we take things by the application. When you're in the micro world, every project is really, really different,
That's great. Hey guys, it's been great having you on. Congratulations. Look forward to, getting the word, helping to get the word out, and to following your success going forward.
Great. We hope you can make it to the grand opening too, Steve, and come back to your roots over here in New England. We'd love to have you.
I'd love to be there, guys. I'm looking.
Yeah,
I'll be,
look for that. Look for the invite.
I will.
Coming out soon.
All right. Thanks, guys. Appreciate it.
Thanks, Steve.